All right, welcome AP Stat students. So this is the video for the FRQ for Unit 9, the quiz, right? Unit 9 FRQ quiz. There's only one question. It's a little bit long, but we'll go through it as quickly as we can. So let's get into it. In the Bassmaster Classic Fishing Tournament, each competitor can only keep 5 bass to be weighed at the end of the tournament. With over 60 competitors, there are over 300 bass that are measured and weighed at the end of the tournament. Here are the lengths and weights for a random sample of 10 bass from the most recent tournament, right? So you have you have a few things there, right? So let's dive in and take a look at what we have there. So we have the scatter plot, right? And which looks linear. And then we have the residual plot, which looks random. And then you have the dot plot of the residual. That looks pretty, without strong skewness or strong outliers. And then you have the computer output. So let's look at part A. Interpret the slope of the least square regression line. And the slope, you can easily find it on the computer output, which is 1.5858, right? Small b, sample slope of the 10 bass is 1.5858. Now, how do we write the interpretation of the slope? Now, we have to write it for every increase, right? Because it's positive, right? The slope is positive, 1.5858. So for every increase of you have to look at the measurement of the x variable. So in this case, we are looking at inches, right? 1 inch in length, right? Comma, the predicted. Now, this is a big word. This is a very important word that you have to put, because slope is, when you interpret the LSRL, we are using it to make prediction. So you have to use the word predicted, and they are looking for the word predicted. So the predicted increase, because it's a positive slope, in weight increases by, then you got to put in the value, 1.5858 pounds. Right, part B, construct and interpret a 95% confidence interval for the slope of the population regression line, right? We're talking about the population LSRL for the length, which is the X variable, and the weight, which is the Y variable, for all bass at this tournament. So, first thing first, we need to put the 4-step, right? First step, state. Now, what are we stating? We're stating the name of the test, because this is a confidence interval, right? We don't need a hypothesis. We don't need significance level, but we do need to put the name here, right? So sometimes we put the name in the do part when we do the significance test. But here we can put the name immediately for the t interval. Why t? Because slope is a quantitative data. So t interval for slope at a 95% confidence level. Now beta, we have to write our parameter, right? Beta is the true slope of the population LSRL for the length, which is the X variable, and the weight, which is the Y variable, for all the bass at this tournament. Next, we need to put plan, right? After state, we have plan. Now, what's the plan going to involve? It involves all the conditions. So what are the conditions? You have the acronym LINER, liner, right? Or linear, liner. So liner, first one, L is linear. Now, what do we look at? We look at the scatter plot. So the scatter plot is fairly linear, right? It has a linear pattern. And the residual plot shows no pattern, right? If it shows no pattern, that means the linear model is a good fit. Next one, I, independent. Now, we have to write 10 because that's the sample size, less than 1 out of 10. Now, are we looking at all bass in the world, or are we just looking at the 300 bass? So we are only looking at the all 300 bass in the tournament. So normal. Now, what graphs are we looking at? We are looking at the dot plot, right? The dot plot of the residual, right? It has no strong skew and no strong outliers. So next condition is equal standard deviation. That this is pretty standard, right? You look at it and see if the residual shows any linear similar variability. If it has similar, you just put similar variability for each x. And that should suffice, right? That should work. R, random, right? Somewhere in the statement, there should be a statement that says random sample of however number of whatever context this is. So random sample of 10 bass. So the do part. Now we can write the specific formula right here, right? Very quickly, we can put sample slope, which is small b, plus or minus t star, because this is t interval, multiplied by the SEB, the standard error of the slope. Now we know the b is 1.5858 plus minus, oh, what is our t star here? So we need to calculate t star, right? T star is, you can use your calculator, inverse t. We need to put in the confidence level at one of the tail, right? One of the tail, so that should come up to 0.975. And we need degrees of freedom. So here the degrees of freedom is n minus 2, so which is 8. So we need to write that down somewhere. So degrees of freedom is 10 minus 2, which is 8. And we need to put down, okay, so using the calculator, the t star comes up to 2.306. So we need to continue, right, putting it the t star, which is 2.306. From the computer output, the SEB is 0.1535. And that, when you work it out, the interval is 1.23 to 1.94. So let's conclude. We are 95% confident that the interval from, so this is pretty standard, right? It's always the same way we answer for any kind of interpretation, any kind of conclusion for interval. This is how we write it, right? We are 95% confident that the interval from, then you put down the interval 1.23 to 1.94 pounds per inches. Now, why pounds per inches? So slope is what? Slope is change in y over change in x. So here the y is weight, which is pounds, and change in x is length, which is inches, so pounds over inches. So captures, right, that's an important word, captures the true slope of the population LSRL4. Now this is all very standard. For what? What's the context here? For the length, which is the x variable, and the weight, which is the y variable, for all bass at this tournament. Okay, so part C, write hypothesis that would be used for a significance test to determine if the results provide convincing evidence of a positive relationship between length and weight for all bass at this tournament at an alpha of 0.05. So, to write hypothesis, we need H naught, right? Null hypothesis, H naught, and beta equals to 0 because we are assuming that there's no relationship. So when there's no relationship, slope is 0, right? The population slope is 0, beta equals to 0. HA, alternate hypothesis. Now, we put beta is greater than 0. You know why? Because in the question, we are trying to find convincing evidence for a positive relationship. So if it's positive, the slope will be more than 0. So part D, what are the test statistics? Now, the formula for test statistic, right? You would think that I would know how to say that word by now. Statistic, right? There's a formula which is small b over SEB. Now we know what small b is, which is 1.5858, and the SEB is 0.1835. And that gives us a test statistics of 10.33. So p-value, right? We need the test statistics to help us find the p-value, and we need to use TCDF. Now we have the lower, which is 10.33, and then we need the upper. Ooh, you must be wondering, why would lower be 10.33? Now the best way to convince anyone is to draw a graph, right? So I'm drawing a graph, normal curve, put 0 in the middle, and where's the test statistics? 10.33, which is to the right, and we shade to the right because it's more than, right? So here, the lower bound is 10.33, upper bound has to be 9999, right? And then degrees of freedom is 8. That puts us to have a p-value of 3.33 times 10 to the power of negative 6. So if you write it out properly, it will be 0.00000, that's 50, right? 333, which is really small. So part E, we're supposed to make a full conclusion that includes an interpretation of the p-value. If we need to write the p-value, the interpretation of p-value, you need to know how to write this properly. I don't know if this is necessary, but just please learn and write it properly so that you know what to do. So how do we write p-value? Assuming h naught is true. And what is h naught? Beta equals to 0, right? There is a 3.33 times 10 to the power of negative 6 probability, right? It's a chance, probability of getting a sample slope of 1.5858 or greater, right? Because it's more than. The alternate hypothesis says we're trying to find evidence that the population slope is greater because it's a positive relationship, right? Purely by chance. So that last 3 words, right? Try to remember that that's what we usually put at the end of the p-value interpretation. So because p-value is less than 0.05, we reject the null, h naught. There is convincing evidence of a positive relationship between length x and weight y for all bass at this tournament. So we're trying to say that there is convincing evidence to support HA, right? And HA here in this case is that there is a positive relationship. Okay. So if you have any questions, please let me know. Thank you.